Hello everyone! Today we are going to be learning the divisibility tests for various numbers. And a lot of you may be asking me, what in the world is a divisibility test? Okay, basically, it's just a test to see whether a certain number can divide by another certain number. Okay, so I will give you an example. If I gave you this number like 648329 6, and then I gave you this number 4. I ask you, can this 6483296 divisible? Is this number divisible by 4? That means, can this number divide 4 and leave no remainders at all? You may say, alright, I know, I'm actually very smart. I'm gonna do long division and then see whether I can successfully divide these numbers without any remainder. So you're gonna slowly go ahead. What am I even doing? It's this 4, sorry. Just slowly go ahead, do your long division, check whether it works whatsoever, and then you're gonna be like, oh yeah, you find whether it has the remainder or not. I mean, yeah, that's a valid way to check whether this number can be divisible by 4. But what if I told you there was actually a faster, a more efficient way of checking whether this number can be divisible by 4? And that is using the divisibility test. So, essentially, the divisibility test is a very fast and efficient way to determine whether a certain number is divisible by another number. Now, in the example I used, it was, can it be divisible by 4? But a divisibility test can actually not just do 4. It can do 2, it can do 3, it can do 4, it can do 5, it can do 6, and so on and so forth. So, the divisibility test is actually a very good thing because you can easily determine whether a random number, you can straight away tell me, can it be divisible by 3, let's say, and you can straight away tell me 6, 4. You try to do a little calculations in your head, right? But some of you, your mental calculations may not be that good you do on paper, but it doesn't matter. It's still way faster than doing long division. Okay, now of course, the divisibility test doesn't work for all numbers, which basically means that it does not work for like, oh, can this number be divisible by 136? No, right? That's a bit too over. Okay, divisibility tests only work for certain numbers. Like, can it be divisible by certain numbers? Okay, but it's still good because you're not gonna, most of the time, you're not gonna experience those kind of situations where you have to determine whether a number is divisible by 136, right? Okay, now, divisibility test is very useful because sometimes you need to determine, can this number be can be divisible by a certain number, and you need to like do sort of trial and error to see what can be divided by what. And there are a lot of times you can just go do a super long division and you have to like you waste a lot of time. But with the divisibility test, you just need to look at it and straight away you can know. Alright, and this is gonna be super useful not only just for your knowledge but also your mathematical journey. You're gonna face a lot of these kind of problems where you have to just determine the divisibility of a number. And if you're gonna do long division, it's gonna waste so much of time. Alright? And yeah, it's true. And if you're testing for primality whatsoever, it's gonna be way more important as well. Alright, so for today's lesson, we are gonna be learning the divisibility test for 2, 3, 4, 5, 6. That's all. Okay. There's actually more. There's actually divisibility test for some other numbers, okay? But this is part 1 of the divisibility test video. There's still a part 2 which I will be uploading soon, but maybe by the time you're watching this video, it's already uploaded. So go check out my channel to see whether it is uploaded or not. Okay, so today's lesson is gonna cover the divisibility test for 2, 3, 4, 5, 6. But if you wanna learn the other ones, you can go ahead and check part 2 of the video, which I will attach in the description below once it's released, and then you can go ahead and watch the video and learn the other divisibility tests. But we'll learn 2, 3, 4, 5, 6 first. Okay, so firstly, divisibility. Why my handwriting so messy? S4. Okay, so messy. Boom. This looks better. That looks better. Alright, divisibility test for 2. Now, a lot of you may already know the divisibility test for 2, which is why you're gonna be like sighing. Oh, stupid shit, right? Nah, I know some of you know already, but chill, okay, chill. I know some of you know. Okay. But just for formality's sake, just so that, we can make things official as possible to cover everything in this video, I'm still gonna teach it. Right, but even if you already know the divisibility test for 2, you may not know the reason why. And for every single one of these divisibility tests, I will also explain the reason why it works. So it's gonna be super important because you're not just gonna blindly remember it. You still need to make sure you know the reason, alright? So I'll also be explaining the reason. So some of you may know the divisibility test, but you don't know the reason, you better make sure you watch it. But if you know everything, you'll know it all, then you can go skip to divisibility test possibly. Okay? So let's go through this. Okay, it's gonna be very important. Okay. So firstly, let us, see. Okay. For divisibility test for 2, we all know if a number is divisible by 2, we call it even. Why is my handwriting so bad today? We call it even. If it's not divisible by 2, we call it odd. Okay, this is basic knowledge. Now, believe it or not, if I have a number, okay, maybe you believe it because you already know. Okay, but if I have a very long number, 2, 6, 4, 8, 7, 3, 2, 1, 8, 9, 1, 0, 4, 3, 2. I can literally ignore all these and just look at the last digit. This last digit will determine whether the number is divisible by 2 or not. If the last digit is divisible by 2, that means this entire number is divisible by 2. If this last digit is not divisible by 2, that means the entire number is not divisible by 2, and I'll explain why later. So, we all know these are the 5 digits that are divisible by 2, that are even. And these are the 5 digits that are not, that are odd. So all you need to do is just look at this last digit. See, think about it. Is it even or odd? And we obviously see that it is even, right? So this entire thing is even, is divisible by 2. Right, why does this work? This is the most important part. Okay, I'm gonna break it down with a super simple example. We have the number 78, let's say. And of course, we know that this number is even because 8 is even. Now, I want you guys to agree. This is basic knowledge, alright? If we have a number, A, B, alright? I drew this line on top of it, you should know why, but if you don't know, I'll explain. For example, if I don't draw this line, it will be AB. And this won't make sense because AB is actually A times B. But I want to express a number, an integer that is, AB. Like, for example, A is one digit, B is another digit, and together, right? Then you must put a line on top of it so that you don't confuse it with A times B. So if I put a line on top of it, that means that it's just like one number, A, and then A is the first digit, and then B is the second digit. And then, for example, this is 7, this is 8, this is 78. But if I have AB without a line, then, you'll be confusing. So that's what the line does. Okay, so let's see. If I have number AB, you should know that AB equals to 10A plus B. Because this is the 10th place, so it's 10. This is the ones place, so it's actually sort of like 1B, but you don't have to write that because B is basically 1B is basically just B, so you don't have to actually write that. So AB this is 10th place, so actually what it means is 10A. This is ones place, so this is actually just 1B. Easy as that. Okay, so I think you can probably guess by now if I have ABC, like so, it will just be this. Okay, but enough in the nonsense. Now, here we see this. Alright. 78. It's basically 10 times 7 plus 8. Agree? This is like my 10A plus B. Sort of same thing. 10 times 7 plus B. Now, I'm pretty sure we can all agree that 10 can divide 2. For sure. 10 can definitely divide 2. Agree? So, 10 can divide 2. So, if I take 10 and I multiply by this 8, it will still be able to divide 2. Agree? That one you should all agree. Okay? If I have For example, if I have AB, right, and I'm told that A, let's say, is divisible by 13. That means the entire number AB, A times B, is divisible by 13. This is basic knowledge because it doesn't matter what B is, but we know A can divide 13. So that literally by itself can divide 13. Okay, but if you just want a simple example, 2 times a random number, we get this number. This number can definitely divide 2, right? So now you understand what I'm trying to say? Understand what I'm trying to say? Just now that example, AB. We know A is divisible by 13 times B. That number is also divisible by 13. Same thing, just now that example, 2 times something, we get this number. This number that we get is definitely divisible by 2, right? Right? Same thing. AB, we get this number. And this number is definitely divisible by the roots of the number, which is 13. So now that you get this logic, we can definitely assume that in the format AB, we have 10A plus B. We can definitely confidently say that this is definitely divisible by 2. So now all is left is basically we can this divisible by 2. We know that this is divisible by 2 for sure, 100%. So we can don't look at it anymore. Because this is divisible by 2. So whether or not this entire number is divisible by 2, all lies in the hands of whether this is divisible by 2. Agree? So same logic. 78. We don't need to look at this entire thing because we know that this definitely can divide 2. We just need to look at this last digit. Can it divide 2? And even if we have something like 100, 1,000, 10,000, 100,000, right? Because sometimes you have like A, B, C, D, E, right? Agree? Even at these numbers, we all know that this can divide 2, this can divide 2. So we can completely ignore them. Alright? Now, divisibility test for 3. This one's pretty straightforward. If the sum of digits is divisible by 3, that means the number is divisible by 3. Why? Because I'll explain. But I'll just give you a quick example for it first. 684. Don't know whether this is divisible by 3, doesn't matter. Just take 6 plus 8 plus 4. That is 18. Right? 6 plus 8, 14, 14, 4, 18. We just need to look at this. Can 18 divide 3? Sure can. Right? 6, right? 18 definitely can divide 3. So, this entire number can divide 3. So basically just add the digits up together and see whether that result can divide 3. Now why does this work? Simple explanation for you. I'm going to use the same thing that I did for divisibility test by 2, and you'll be seeing this a lot in this video because I need to explain. Okay, ABC. We all know this, so now I don't have to re-explain this, alright? Because you're going to have to reuse this knowledge for the next few explanations. It's going to be sort of the same thing. So you need to know this first. Agree? Okay, now let us twist things up a bit. For fun, I just want to break this 100 up. I want to break it up into 99 plus 1. And I want to break this 10 up into 9 plus 1. But that's still legal, right? This still makes sense. Right? This, transiting to this is kind of easy to comprehend. Okay, now, let's expand this. You should know what expansion is, okay? Just so you know, in case you don't know, I'll be taking this more in the algebra videos, which I will upload soon. You should know this, okay? This is the distributive law. This times this, you get the whatever number, and then you take this, if you have brackets, to get rid of the brackets. So, same logic, let's expand this. You will get 99A plus 1 times A is just A. Now this expanded will be 9B plus B. This is just C. So we can safely say that this equals to 99A. Let's bring the 9B over first. And we just put the ABC behind. as we've said, as I've covered in the just now, this can divide 3. Therefore, this can divide 3. This is why I've covered it, right? Just now about a 10. If you've forgotten, please make sure you go look at it again. This can divide 3. So this can divide 3, this can divide 3. And just like how we ignore them, we can also ignore them here. Because this can divide 3, this can divide 3, you have to look at it. So now the fates, the whether or not this can divide 3 all lies in the hands of whether A, B, C can divide 3. A plus B plus C can divide 3. Which is basically the entire logic. Right? If the sum can divide 3, that means this can divide 3. The sum of digits. Right? Yeah. So, I'll explain one more time with a bigger number this time. We know that this is 10,000 A. Okay, plus 1,000 B. Okay, plus 100 C plus 10 D plus E. Break this up into 9, 9, 9, 9, and 1. Now, if you see, right, it doesn't matter how many digits a number has, right? What it will probably, like, even if it's a lot, we will probably get something for this number. We will probably get something like this, right? And you notice that as long as we just break it up into 1 and something else, this something else number will always be something like 9, 9, 9, 9, 9, 9, 9. Which can always guarantee would definitely, because we know 9, 9, 9, 9, 9, whatever, is definitely can divide 3, right? So, it doesn't matter how big this number gets. We know that we will probably get something like a million A. Even if it's a million A, we can break it up into 999,999 and 1. Okay? And then this will be divisible by 3. So you can see how it works for anything. So same thing here over here. 91, 1, A. And then over here, 99 plus 1 C plus 9 plus 1 D plus E. And then all we need to do is expand. So now we're just like trying to rephrase everything. And we can just push the A's and B's back. Okay. Wait, sorry. Let me finish writing. Okay. Wait. Okay. Then, now, you see, now we are left with something. We're left with, we expanded these two. Now we're left with this, this, right? Which is all just A, B, C, D. So, A plus B plus B plus D, and of course the E. Okay. Now, see, these definitely all divisible by 3, so don't look at it. We have only to look at this. If this is divisible by 3, then everything is divisible by 3. Now, a divisibility test for 4. Now, this one is also very similar to divisibility test for 2. So you see how it's all linked together, right? I explained quite a long time for the divisibility test for 2. Because once I explain everything about divisibility test for 2, it will be pretty easy to understand for the other few. Because it's also like the same concept, the same logic. So as long as I explain that for 2, it will be much easier to explain for the rest, which will be easy. So if like you were a lazy person, you skip 2, even if you didn't know, and now you're trying to watch 4, you will probably not understand, because I will skip some parts because I already taught them in the divisibility test for 2. So you go look at it again, revisit it, make sure you know, and after you come back here. Because if you're just gonna listen to this without knowing the basic concept, you won't be able to do it. So I'm gonna accelerate things, okay? Now, divisibility test for 4 is very simple. Just look at the last 2 digits. It's sort of like 2. 2 is to look at the last digit. 4 is to look at the last 2 digits. And actually 8 is to look at the last 3 digits. Okay, but never mind that. It's for the next video. Okay, so I'm gonna have a random number. 1, 6, 4, 3, 2, 9, 7, 8, 4. This is divisible by 4. Therefore, the entire number is divisible by 4. Let us go through how this entire thing works. Okay. Now, why does it work? Okay. Now, For the divisibility test for 2, it went something like this. If you have ABC, 100A plus 10B plus C. This is divisible by 2, so we have to look at it. We just need to look at this. Now, same thing. For divisibility test of 4, it's sort of like the same thing. Now, this thing is divisible by 4. So we only need to look at this. Okay, now here's the difference. Okay, you notice that in the first one, I also cancel out this, but this one I didn't cancel out. Why? Because now here's something you should know. Okay, you should know. 2, okay, 100, 1,000, 10,000, 100,000, 1,000,000, so on and so forth. They can all be divisible by 2. Okay, I mean, sorry, they can all be divisible by 4. Now, this also applies for 2. These numbers, they can also be divisible by 2 as well. Okay, but here's the difference. 2 has an extra thing that you know, that works as well. 10. So here's the difference. Okay, here's the difference. For 4, listen guys, for 4, 100 can divide 4, 1,000 can divide 4, all these can divide 4. And you continue moving on, you all can divide 4. For 2, all these can also divide 2. But 2 has an additional 1. This one can also divide 2. So this is additional, which 4 does not have. So which is why, for 2, that's why we can cancel it, because this one can divide 2 easily. But here's the thing. 4, the 10 cannot. So that's why we cannot just cancel it. We cannot cancel it. Okay. Now, that is why. Notice this 10B plus C. Isn't it just the same as saying the last 2 digits? Right? Because I've explained this in the divisibility test for 2, the entire logic of all this, right? Of why this makes sense. So I'm not gonna explain one more time. You go watch it if you want. So same thing. That's why we can say that this whole thing, we just need to check whether this is divisible by 4, which is the last 2 digits. Why exactly this is the last 2 digits I want to explain, okay? Because I've explained it already. So just to make it clear for all of you, so you understand, all right? For divisibility test for 4, it's the same as 2, but just that it's the last 2 digits, not last 1 digit. Because in divisibility test for 2, this green color thing, which expresses it's already divisible, can just cover this off. But unfortunately for divisibility test for 4, this thing cannot divide 4, so we can't just cover it off. Alright, so you need to make sure. Alright, now this is for divisibility for 2, right? This thing 10, 100,000, 10,000, 100,000. This is for divisibility test for 2, because all these can be divided by 2, but they can also be divided by 5, and I'm pretty sure you know why. They can all be divided by 5. So that brings me to the next one. Oh, I know space. Divisibility for 5. And since we know that all these can be divided by 5, I want you guys to pause the video and tell me what do you think is the divisibility test for 5. Alright, pause the video, try it out. Okay, use your prior knowledge to try to you know, understand what you think is the divisibility test for 5. Okay, now I'm gonna make it super straightforward. If I have ABC over here, if C is divisible by 5, that means the entire thing is. Now that basically means C divided by 5 means 0 or 5, because 0 sort of stands for like 10, and 10 is divisible by 5. So you just need to make sure, can this last digit be divisible by 5, which really means it's either 0 or 5. Okay, that's how easy it is, because the rest we already know is all covered. Okay, so I'm not gonna explain much. Okay, now divisibility test for 6, you're in for a ride. because this one is gonna be a bit more complicated to explain. I need to explain co-prime numbers. It's gonna be quite long. Okay, so guys, bear with me. I need all the space. Okay. Test for 6. Now, it's super simple. The divisibility test for 6 is basically just need to satisfy two things. First thing, it can be divisible by 2. Second thing is divisible by 3. You just need to satisfy these two. The first one is divisible by 2. Second one is divisible by 3. As long as you satisfy both, it is divisible by 6. Now, a lot of you may claim, the reason why this is so is because 2 times 3 is 6, which is technically correct. But now I want you guys to think about this. Can I just say this? Can I say this? Alright? I want you guys to think of this super weird explanation. Can I say 2 times 3 is 6, agree? So, 2 times 4 is also 8. Right? So, with the same logic, can I say the divisibility test for 8 is you can divide 2, you can divide 4, therefore it's divisible by 8. Because that's what we did for divisibility test for 6, right? We just need to satisfy the two conditions. Can divisible by 2, can divisible by 3. Which is why it's divisible by 6. So, can I just say that it works the same for this? Divisible by 2, divisible by 4, divisible by 8. No. I'll explain why. Okay. Now, firstly, can we all agree on something first? Okay, this is the first thing you need to know. If I have the number A, I have the number B. Alright. If a number is divisible by A, and it's also divisible by B, that means it's divisible by the LCM of A and B. And LCM basically means lowest common multiple. Alright, and I'm pretty sure this is like very easy to understand why this makes sense. If it's divisible by A, it's divisible by B, right? That means there's nothing to interfere. That means it definitely can be divisible by the LCM of A and B. Okay, but if you don't understand, I can explain it in an easier way. Now, A and B, they have certain prime factors. They have certain prime factors, agree? Now, if this number is divisible by A and also divisible by B, that means it can be divisible by all these prime factors, right? That means you can divide by this, all these prime factors, also all these prime factors. And let me ask you a question. Which number has all these prime factors all together? The LCM of A and B. Agree? So it's sort of like saying A is made out of these ingredients. Like A is sort of like a cake. It's made of these ingredients, which are the prime factors that build this A up. And B is also made of some ingredients, the prime factors that builds B up. So if I want to check whether, so therefore I can just combine these two ingredients together, the two prime factors together, and of course it will be the LCM, right? We'll learn this more in the prime factorization video, which I will definitely upload for y'all. But just to make it clear for y'all, the ingredients of A, ingredients of B, which number has both ingredients together, all the prime factors together, is the LCM, right? And it's not just any multiple, it's the lowest common multiple. It's not any common multiple between A and B. Because if it's like something like, if A is like 2, B is like 3, the LCM is 6, right? And then we can also, another common multiple example could be, I could give you another thing that's also, that's also makes sense, 12. 12 is also a common multiple of 2 and 3, right? But it's not the lowest common multiple. And then some extra unwanted ingredients are added in. So think about it this way. A has some ingredients. There's A ingredients inside. There are the B ingredients as well. The LCM of A and B are the ones that have exactly A and B's ingredients. Both of them. So let's say A's ingredients are these things. B's ingredients are these things. The LCM will basically just be both together. Which are, Now, we can't just have any common multiple. It must be the lowest common multiple. Because if I add in other stuff, we may accidentally introduce some unwanted things. For example, A equals to 2, B equals to 3, right? Now, the LCM, we know it's 6. But we definitely can only use LCM. We cannot use a random common multiple. Let's say I use 12. Yes, 12 is a common multiple of 2 and 3, but it's not the lowest. And see what it has done? It has added in some unwanted ingredients. What has it added in? A 2. Because 6 times 2, you get 12, right? This is purely just 2 and 3's ingredients, which is only 2 and 3, because that's their prime factors. 2's prime factor is 2, 3 prime factor is 3. So together, it will be 2 times 3, 6. That's the lowest common multiple, and that is okay. But you cannot add in some other stuff to contaminate it. That's why it must be the lowest one. It must be the lowest, because if you have just a random common multiple, it may have some unwanted things. In this case, it has another extra 2. So yeah, it doesn't make sense. It doesn't work. So this is the first thing you must know. Divisible by A, divisible by B, that means divisible by LCM of A and B. So now let's go back to the previous example. We could say that 2 is divisible by 2, is divisible by 3, that's why it's divisible by 6. But we can't say if it's divisible by 2, it's divisible by 4, it's divisible by 8. Why can't we say that? Now, here's the thing. Because this one satisfies this. 6 is the lowest common multiple of 2 and 3. So, we have agreed that if it's divisible by A, it's divisible by B, that means it's divisible by the LCM of both. So, in this case, it's divisible by 2, is divisible by 3, that means it's divisible by the LCM of 2 and 3, which is just 6. But in this case, if it's divisible by 2, it's divisible by 4. It's divisible by the LCM of 2 and 4, which is not 8. It's 4, right? Which contains the ingredients of 2 and 4. If we have 8, we are adding in unwanted ingredients like 2, which we don't want. So that's exactly why this works. Because this is the true LCM, but this is not the LCM, so that's why it doesn't work. And how do we know whether it's the LCM or not? Now, if the two numbers are co-prime, what does co-prime mean? Now, co-prime means that both numbers' highest common factor, HCF, is 1. Now, we all know that a prime number is when it only has two factors, 1 and itself. But a co-prime numbers, basically there are two numbers, a pair of co-prime numbers. That means both numbers, together they have a highest common factor of only 1. Which means that they do not share any common factors except for the most basic one, which is 1. That is the first thing you must know. Because if I have two numbers, A and B, maybe it will share some factors. For example, if I have 6, I have 4. They share a factor 2. But if I have, for example, let me give you an example. I have 2 and I have 3. They only share one single factor, which is just the number 1. They don't share any other factors. Okay? So that's basically what co-prime means. Now, why is co-prime so important? Now, the reason is because to find LCM, agree that this is the formula to find LCM. I want to find LCM of A and B. It's basically just A times B over the HCF. But if the HCF is 1, then you might as well just not divide it. You might as well just stick with this. So here's the thing. If the highest common factor is 1, which basically means co-prime, if the highest common factor is 1, means that this is co-prime, then the LCM will be A times B. See this? Picture this. LCM equals AB over HCF. This makes sense because the reason, now usually LCM just equals to A times B, but we need to make sure that we divide HCF because we need to clear all the overlap things because they have common factors, right? So they will overlap. For example, if we have something like 2 and 4, right? Can we just say it is 2 times 4? No, because they share a highest common factor, which is actually 2, right? So we know that there's a copy of 2 here. There's a copy of 2 here. Agree? Because they all have the same common factor. And if we multiply together, we won't get the lowest common multiple. So we need to make sure that we clear up all those unwanted stuff inside. In this case, this number has an unwanted stuff, which in this case is 2. This number has an unwanted stuff, which is 2. And you notice how they both have 2. And in LCM, we need to make sure it's the lowest possible. So we cannot have overlapping things. That's why we need to, this is the HCF they have, right? We need to divide by the HCF so that we can eliminate one of those. So that it will be pure as possible. It will be the true lowest common multiple. Basically, you just find the product and you divide all the overlapping stuff. So in this case, this part overlaps. So take it out, you only have this left, which is the true HCF. Alright? So, true LCM. So in this case, AB over HCF. But what if they are co-prime and HCF is 1? That means LCM just equals AB. AB over 1 just AB. Right? So notice how if it's co-prime, that means HCF is 1. And if HCF is 1, that means LCM equals AB. It's all like a chain reaction. If it's co-prime, HCF is 1. And if HCF is 1, LCM will be equals to the product, which is just AB. Now, back to this. Back to why 2 and 3, 2, 3, 6, and 2, 4, 8. Example here. Why does it work? 2 and 3, they are co-prime. 2 and 3 are co-prime. So, therefore, their LCM would just be the product, as we have gone through over here. Right? They'll be the product. But in this case, 2 and 4, are they co-prime? No, they are not co-prime. That's why their LCM will not be that product. Okay? It will be their product. It will not be our product. Okay? You have to divide by HCF, remember? You have to do this. You have to do this. Okay? So, that's it. That is literally why it can work for divisibility test for 6. Because 2 and 3 are co-prime. And in fact, it can work for any other 2 co-prime numbers. So, if, for example, we can actually find whether a number is divisible by 42 or not, just by checking whether a number is divisible by 6, divisible by 7. Because 6 and 7 are co-prime. If you notice, 6 and 7 are co-prime. So I can straight away snap my fingers and tell people, okay, if it's divisible by 42, that means it's divisible. If it's divisible by 6 and it's divisible by 7, that means they're co-prime. That means divisible by 42. So that's why it works here. And literally, divisibility test by 6, you just need to do the divisibility test by 2, do the divisibility test by 3, and you can check that both of them are ticks. You know, check the boxes, and you know this works. Okay, so thank you very much for watching, guys. I hope you enjoyed this video. I hope you learned something. Alright, I will see you guys next time in the next part 2 of this video where I will teach and explain even more divisibility tests. Alright, so if you like this video, guys, I will explain more in the next video. It will be part 2. You will learn more stuff. You will get filled with knowledge. Alright, if you like this video, please consider liking and subscribing because you liked it, right? If you liked it, of course you must like it, right? It makes sense, right? Okay, so thank you very much for watching. Peace.